I'm going to show you how to make this liquid vial effect. Before I do, real quick, I just released my game Sword Slinger on Steam. It was made with the Godot engine. If you like my channel, please check it out. Link in the description. Okay, let's get right into it. So first off, I have a rigid body 2D as my root node. The only reason that I have this set up is because I wanted to get free rotation over time without adding any additional code. So I just have the angular velocity here set to 3 with a damp of 0, and also gravity scale set to 0 so it won't fall off the screen. And then I have a sprite node here with the vial.png image in there, and with an offset of -4 in the Y. Okay, so now we're going to go ahead and add our liquid sprite. Now before we do that, you want to take your liquid animation, which should all be separate images, by the way. Each frame should be a separate image. That just makes the effect easier to achieve. Select all of your animation images and go to preset, load 2D pixel or whatever your appropriate preset is, and then set the repeat flag to enabled and re-import all of those. And you'll see why that's important. So your animation, each frame in your animation needs to be tileable, so that's very important. Okay, so let's go ahead and add a sprite node, and we're going to call this our liquid sprite. And go ahead and just drag over the first image there. Okay, so we now have this beautiful green block here. What we're going to do is we're going to enable regions. So go to the regions section here and click enabled. And then you're going to want to set something sufficiently wide such that it covers the whole vial no matter how it's rotated. So I'm going to use a width and a height of 64 here. And that's going to, as you can see, tile that single image with those dimensions. Okay, and then under the visibility here, we're going to click Show Behind Parent, and now we can see the vial. So this is important. So now if I rotate the vial sprite, you can see no matter how it's rotated, there's always green filling the inside. Okay, so let's go ahead and mask this out, and then we'll animate it. So add a light 2D node, and this is going to be our mask. Now, I have this vial mask.png, drag it into the texture. And what this does is it's essentially just a white bunch of pixels. I don't know if you can see that. It's a white bunch of pixels that sort of outlines the interior and fills the interior of the vial. And so when we change this to mask, it's going to hide everything that's outside of that white part. So go ahead and change the mode to mask, and you can see we're kind of getting there already. Okay, and then in the light 2D node, set -4 for your offset. Now you'll notice that this has masked out our vial sprite as well. So we're going to go to the range section here of the light 2D and change the item call mask to something else. I'm just going to use the last bit here, layer 20, bit 19. And you'll see that everything comes back. So we're just going to pop back into the liquid sprite, and we're going to change the light mask under the canvas item section to the same value, bit 19, layer 20. Okay, so now we can see that our liquid is being contained totally within our vial. Now the other thing we want to do with our liquid sprite real quick is we're going to not center it, and then we're going to set the offset in the X to -32. So we're going to center it only in the X so that our origin is at the top center. Okay, and then you can go ahead and move this into whatever position you want. This is probably good. Okay, so let's go ahead and animate this now. So add an animation player to the liquid sprite node here, and just go ahead and add a default animation. Click autoplay on load over here and click loop. And we're going to set this to 0.8 because we have 4 frames in this animation and I want each frame to last 0.2 seconds. So go ahead and add a property track here for the liquid sprite and the texture of the liquid sprite. What you're going to want to do is insert your first key, which is whatever you have it set to, vial liquid1.png here. Okay, let's change the snap here to 0.2 seconds, and we're also going to zoom in on the track a little bit. And just go ahead and add another key, and then drag in your second image over here, and then do the same, insert another key, drag in the third image, insert another key, drag in the fourth image. Now let's go ahead and play this. We can see now that we have our texture being animated very nicely. Now that's a little bit slow for me still, so what I'm going to do is just click on the animation player node here and change the playback option speed to 1.5. So now I got something that's a little bit quicker and more pleasing to look at here. Okay, we're basically going to follow the same exact process for the crest, which is the animation that we're going to play on top of the liquid. So to make this more visible, I'm just going to bump this down. Yeah, that'll look really good. And add another sprite node as a child of our liquid sprite. And you can call this one crest just for clarity. Drag over our Vial crest 1 and also disable centering. Now before we do any more centering here, we're also going to enable the region on this one. So we're going to enable it. Our height is going to be 16 because that's how tall our single frame of the crest is. And the width is going to be the same width as the liquid sprite region width. So we're going to call that 65 there. And then go back up to your offset and do -32 in the X and -16 in the Y. So you can kind of see where we're going now. We're going to animate this thing over the top. And we're also going to mask it in exactly the same way. So let's go to crest here, click the visibility section over here, and change this bit to on, bit 19, layer 20, just like we did for the liquid sprite. Okay, so now we can see that we have that crest being overlaid, and we're going to do the same exact thing to animate it. So go ahead and create an animation player under the crest node, call it default or whatever you like, autoplay on load, and animation looping, and then create a property track for the crest texture. Insert your first key, and then we're going to change the snap to 0.2 again, and just go ahead and do the same thing. Drag over crest 2 in a new keyframe, insert another keyframe here, and drag that over. And we are going to end this after 0.6 seconds, and we're going to click play on this. Okay, so you can see now we actually have a really nice looking crest. Now I'm also going to bump this playback option up to 1.5. And this actually looks like it's going the wrong way. So let's just change it to -1.5. And now we got something that looks really nice. So you can see the benefit of making this crest a child of the liquid sprite is we can move this up and down now, and the animation follows it. Okay, we have a few more setup steps to do before we can get into the code. So let's add a reference rectangle. And the reason we're using a reference rectangle is this is just an easy way to visualize and store data about the general dimensions of the vial. So what I'm going to do is I'm just going to move this into the top left and align that with the top and the left edges here. And then the rect, I believe it's 18 pixels wide and 25 pixels tall. I just remember those numbers. You might have to do a little bit of discovery there. So yeah, the reference rectangle, like I said, it's basically just going to be used later in the script. We need to get the width, the quote-unquote width of the vial. You might not have to use a reference rect if your sprite is, cropped. You could probably just use the sprite width. I just think this is a nice, easy way. And also, if you need the height information later, that's also baked into this reference rect. So it's just a nice way of sort of visualizing and also storing data, like I said. Couple more things to add. Go ahead and add a position 2D. Call this max fill position. And put it wherever you want your liquid to be at when it's 100% full. So I'm going to move it up a few pixels away from the origin here. And just to visualize this, this is what it's going to look like when it's 100% full. This liquid is going to be at that max fill position. So that's what that represents. And we're going to duplicate this node and call this one min fill position. And this is going to be exactly the opposite. So I'm going to move this down to where I want the 0% value to be, or the 0.1% value. You might have to add a little bit of logic if you want it to be totally empty at 0%, but this is where I want it to be at an absolute minimum. And so what that's going to look like is I'll just scoot the sprite down here. That's what's going to look like at minimum fill, which I'm calling 0%. Okay, so that's it for the setup. Let's take a look at the code. Now, I've already pre-written the code just for speed purposes, but I'm going to go through it one line at a time here. Okay, so we're exporting a variable called fill%, which is a range of 0 to 1. You could actually enforce that with a property hint, but I didn't do that. So 1 is max fill %, and 0 would be min fill %, right? Okay, these ones are going to take a little bit of explaining here. So basically, the problem is when you have the vial, and let's say it's rotated 90 degrees horizontally, what's happening is we've put our max fill and min fill positions based on the height of the vial when it's upright. The problem is the height of the vial changes when it's rotated, right? Now this height is what used to be the width. So you can see that this new height is actually 18 pixels, while the old height was 25 pixels. So that must mean that we have to compensate for that with our max fill and min fill positions. And so that's what those properties represent. This is how much should we shift the max fill line down when the vial is horizontal, and how much should we shift the min fill line up when the vial is horizontal. Now I've expressed these both as positive numbers and then just done the appropriate math later on, but we'll go over that. And then I am storing the vial width and the vial height. You will not need the vial height for this one, the vial width, but I have those in there just as examples of how you can pull it out from your reference rectangle. So in the ready function, we have the vial width and the vial height, and I'm just pulling that right out of the reference rect size.x for the width and .y for the height. Okay, I'm going to jump to this end function down here because this is an important part of what we need to do. So what I'm doing is I am returning a vector in this getRotatedBase function that is the up vector times the vial height and then rotated by the vial global rotation. So what I'm essentially doing is I'm saying, okay, when the vial's upright, this is the resulting vector that I'm going to get, right? Because I'm doing a vector2.up times the vial height as determined by the reference rectangle. But if I rotate this, now my height is slightly different, right? Or my vector, my up vector for the vial is slightly different. And if I measure this now, see, this is still 25 pixels, but now there's an X and in addition to a Y component with this. And what we're essentially going to do is we're going to use that X component to determine how much to offset these max and min fill positions. Now, I know that might not make total sense right now, but I'm going to go through the rest of the code, and then I also have a visualization to show that. So this is basically just rotating the up vector with the length of the vial height. So that way we can pull out the X component for use later. Okay, now in our process function, the first thing we're doing is we're setting the global rotation of the liquid sprite to 0. And this is because you probably noticed if I rotate this, the liquid needs to stay horizontal. It can't rotate with the vial because that's not realistic, right? So we're setting the global rotation to 0, which is always going to keep it horizontal. Then we're calling this getRotatedBase, which I just described, and normalizing it. So that is going to give us our X component that we need for this next step. So this next step is I'm taking the absolute value of that X component and multiplying it with itself to get the shrink percent. So what I'm essentially doing is I'm saying the X component of the normalized vector from this rotated base is going to be used as the percent that determines how much we're going to offset the max fill line and the min fill line. And the reason I'm just multiplying these together or squaring the number is because when you are transitioning between 1 and 0 and 0 and 1, it's going to present a smoother animation. There's not going to be abrupt changes in direction. It's going to slow down as it approaches 1 and then speed up as it approaches 0 and then slow down at 0 again. So it's kind of like a curve, right? Okay, now this max height offset and min height offset. This is where we're using these variables that I was discussing earlier. We're taking this max fill shrink amount, which is 2 pixels down, and multiplying it by the shrink percent. Now remember, the shrink percent is based on the X component of the rotated base, right? And this should actually be rotated height, but I'll change that. Okay, so I actually just changed that really quick. So we're taking the X component of this rotated height, and we're using that as the percent which is determining how much we're shifting the max fill line down. So this max fill shrink amount is going to be 0. This multiplication is going to end up being 0 when our shrink percent is 0. And our shrink percent is going to be 0 when our x component is 0. And our x component is going to be 0 when we are totally upright. So again, to go back to the visualization here, we're upright here. So I'm essentially just grabbing this vector. There is no x component. All of the length comes from the y component. And since there's no x component, we're not going to shift the min and max fill lines at all. Now, if the vial is rotated like this, well, now we have an x component, right? Our x component now is 15 pixels in this example, but we're normalizing it. And so then it becomes a range of 0 to 1. And let's say that it ends up being 0.5. Well, we're squaring 0.5 and then multiplying the max fill shrink amount by that much. And so we're going to get, a number less than 1 as a result to shift down. I'll show you a visualization of this later, but we're basically doing the same thing for the min height offset. We're taking that min fill shrink amount, which is actually larger. You can set two different variables or two different values for these things because of the shape of the vial. That's just really the reason why you would want to use different values. And once we have those height offset values, I'm creating adjusted max fill variable, which is taking our local position of the max fill position and then adding that offset that we just calculated up here. And then I'm doing the same thing for the adjusted min fill. We're taking the min fill position, the local position, and we're subtracting here. Now I could have made this negative up here and also done addition, just math, but I think it was made more sense to keep these consistent and then do the math correctly down here. Okay, this is the visualization I was talking about. So I'm going to skip to this part. So then we're setting the global position of the liquid sprite to the global position of the vial. So we're starting at the middle or starting at the origin of the vial. So right where the liquid is now, you can imagine it's going to be set right there at this step. And then we are adding to the global position a linear interpolated value. So we're going from the max fill, this adjusted max fill position. So this is after we've adjusted for the rotation and the offset. We are linear interpolating to the adjusted min fill value, 1 minus fill percent. So if we're 100% full, we actually don't want to do any more. We don't want to linear interpolate any distance to the adjusted min fill. So this is just going to be a pure addition of the adjusted max fill. I hope that makes sense. So if this was 0%, then we'd go all the way, the offset would go all the way to the adjusted min fill. Okay, I hope that makes sense. Let's get into the visualization. All right, so what I've done real quick is I've just added some sprites here, used the sprites that were in the project, changed their modulate and their scale. So we just have red squares essentially that we can look at. Now what these red squares are going to track is the adjusted min and max fill positions, so you can really get a good idea of what's going on. So I'm going to go to the code and I'm just going to uncomment this, and this is just setting all the positions and rotations appropriately. So let's play that. Okay, so you can see that as the vial transitions from upright to horizontal, these min and max fill positions pull in towards the center. Now, this is not very visible when I'm at 100% fill, but let's change the fill percent to 0.5 and take a look at what that looks like. Okay, so now we can see this. So you'll notice that the liquid is actually moving up and down because those min and max fill positions are shifting. And this actually serves two purposes. One, it sort of models at least a little bit volume displacement, kind of. You expect this quote-unquote height of the liquid to change depending on what the volume situation is like, right? How much space can it fill, which changes depending on the orientation of the container. So it kind of models that. It kind of fakes it. It doesn't really model it. But also, it adds a little bit of what you could call a sloshing effect, right? So if I speed this up, let's say to 5 or something, is that going to work? Yeah, so I've sped this up. So now it looks like the liquid is sort of being almost sloshed around. Now you can imagine how this would be a very believable effect if this vial was much smaller and if you were sort of working with a pixelated game. Maybe you could add an extra shader distortion to it to really sell the effect. But yeah, so it's just sort of making it so that the fill percent, the value where it's filled to, or the line where it's filled to, is dynamic based on the rotation of the vial. That's essentially all we're doing with that code. And it turns out being a pretty decent effect here. So that's the effect. I hope you found that interesting. I used this technique in my Ludum Dare 47 game entry Grave Juice. I'll put a link to that in the description if you want to check it out. But yeah, that's the effect, and I'll see you in the next video. Thanks for watching this video. If you enjoyed it, please like and subscribe. Consider supporting my work by purchasing Swordslinger on Steam. Link in the description.